myself, I'm Andrea Capanaro, working since a couple of years at the Novum as an expert business analyst and taking care of business development of our machine learning solutions since over 15 years in IT consulting, software development. And the other me is a private chef, so I also do cooking events, and I always have a good backup plan to please my customers, let's say. Ire.
Hi everyone. So I'm Ire. I'm an ML engineer. I've worked on a variety of projects for Novum in different areas of machine learning. Security is one of my also pet topics. And when you don't find me behind my computer, then I'm probably either on a lake or the sea on a boat. And if it's too cold, like now, probably in the mountains.
Thank you very much. Good. So I'll just lead you through the first introduction in this webinar. So we're just going to talk quickly about at Novum and what we do in the area of machine learning. We'll also talk about some few selected use cases before then handing over to the core of this webinar. So we'll zoom in on machine learning security. We'll see what kind of attacks are frequent or exist, how to prepare for them, and in the end we'll have an open discussions. Good. So few words about at Novum. We're specialized in delivering secure end-to-end solutions. We do that since approximately 30 years. We're headquartered in Switzerland, and we also have a Singapore office with the Vietnam satellite around for the nearshoring. We operate mainly on 4 markets: banking, insurance, public sector, and logistics and transportation. And over 70% of our population are engineers, so and has a scientific degree. So I think a good proof of it is that both me and Ire are engineers, so we're actually fully landing in this percentage. As an end user, you might have come across or used some of our software solutions just simply by paying with Twint or booking a car with Mobility. Basically 2 of the projects that we helped our customer to develop and scale. Those are just like few examples that I selected, but that's the kind of solution that we usually help our customer to design, develop, and scale. Coming to zooming in slightly on software development, just to have a closer look, you can see that we support our customer actually in the whole life cycle. So starting from analysis, UX, architecture design, to the development phase, the testing, the releasing, the scaling, and also the after production support. Machine learning is of course part of our stack and sits right into the development. Here you can go to the next slide. And before talking about security, we'll have just a look at the, let's say, the kind of use cases that we helped and we delivered in projects for our customers. Starting from information extraction from media. That's a typical example. We delivered this on multiple projects. One of them is, for instance, the AI platform that we helped RTS building to manage in a more efficient and smart way their media. So on the operational efficiency side, we help them depending less on their archivists. So when basically that's usually had to analyze ton of data and manually mark and extract and type the metadata. That's something that it's done now automatically by an algorithm. And not only that helped them on the operational efficiency side, so being more efficient and having less dependencies in their processes, it also kind of helped them on the business reinvention side, so becoming a potential solution provider and basically providing their media archiving solution to other company and that would like to basically put smart features on top of their media. Another case is that we work together with our partner Speech and integrate their voice solution. We help a lot of customers in public, especially and insurance sector, to integrate voice technology that is able to understand also Swiss German, very important in where we're in our market. And enabling better customer experience, leaner operations in call center, for instance, to decrease the call loads on call center side and improve the customer satisfaction, not having to wait in line and having bots being able to answer the most common questions. A good example of it is the Road Authority of Aargau, that is today one of the largest voice bot implementations with over 330,000 calls per year. So that's one of basically the projects we delivered with this technology. And then that moving to enterprise and cognitive search, a topic that is relatively interesting, especially, I mean, in several markets, but currently we see a lot of interest in that for the insurance sector, where, for instance, underwriter could leverage historical data in risk calculation. So being able to find similar policies, see how that was handled in the past, and basically propose solutions with less effort than the, let's say, old school work of talking to colleagues and collecting information from multiple systems. And finally, our tailored offering that we basically provide depending on the customer maturity. So for lower data maturity customers, we help them to define ML use cases, so helping them to generate value out of the data. And for medium to higher maturity customers, so where basically a data team is already in place and some solutions are productivized, that we basically provide also a more in-depth version of the webinar that we do today in form of a training, of an awareness training.
Thanks a lot for the introduction, Andrea. So I'm gonna talk to you about the beef of today's webinar. So machine learning and cybersecurity. So there's actually quite an intersection between these two fields. The first let's say element is using machine learning to attack computer systems. So this can range from discovering vulnerabilities automatically or generating phishing emails. You've probably seen impressive stuff with the deepfakes on the media or on the web. A second avenue is kind of the inverse, which is using machine learning to defend your systems. So from anomaly detection and network intrusion detection, or spam filters, and making user authentication more secure by looking at the patterns of how people log in, how they type their password, and so on. Not just making sure that it is right. But the main topic that we're going to look at today is really adversarial machine learning, which is when machine learning systems themselves are attacked. So we're going to see a few how this can happen. There are different types of attacks where the goal is really compromising the machine learning system to generally either do something wrong, like make a bad prediction, or simply stealing intellectual property. So why machine learning security? Yeah, I mean, Microsoft conducted this survey, and as you can see here, while most companies didn't feel concerned enough or didn't have the time to get onto it. And well, we've seen with our current security, let's say, in the ecosystem of applications and companies, that attacks are more and more common. We see ransomware on the news, and we know that there are more and more risks for companies since they rely on their digitalized systems for more crucial processes than probably 10, 20 years ago, and cybercrime pays. However, all these all these type of attacks or things that we usually prepare for are kind of these known unknowns. So classic, something that I will call classic cybersecurity. And when we're talking about machine learning, then it's kind of one step further. Some companies are not even on that train yet, but the the attack exposure there is quite unknown at large. However, this doesn't mean that it's not exploited. Quite a few companies have actually suffered from attacks on this, and if you may be tempted to think, yeah, but those are kind of huge and worth targeting. Um, this is not only the sole mechanism into play. There's have machine learning has been developing at a super fast pace in the last few years. And with it, the amount of discoveries related to attacks or vulnerabilities has also grown in proportion. So it's also a matter of time that this become more common, both the reliance on machine learning as their vulnerabilities. So we're here to try to keep you ahead. So if we simplify what is machine learning, I'm sure this is not intended as a course, just as a kind of a small reminder, or we start from the same understanding. So we have a data, and in a very simplistic way, we have in a supervised example, we have different classes that we want to classify. We provide this during training to an algorithm, and then we get a model. And once we have this model, then hey, we can provide it with new non-annotated examples, and it will hopefully produce the right label for them. And what, in terms of cybersecurity, what is the impact of that? Well, it means that the logic, or what our computer is running to make new decisions, the software basically goes from what we see on the left, something that is made by humans and also meant to be read by humans, which a machine can also interpret, into a series of weights and parameters that do a calculation, and we get a result. So this is not like a traditional cybersecurity approach. Doesn't necessarily work very well for a machine learning. On one hand, because while static analysis is next to impossible, then there's the probabilistic nature of machine learning, in the sense that even if you have like a 99% accurate model, then on average, one of every 100 predictions will be wrong. And even if you improve that accuracy, there's always a chance that it will make a mistake. Whereas with traditional software, you can find a bug, you can create a test case, and you can fix the code for that. And that becomes much harder, since, well, all of these parameters not only are very impossible to interpret, but they are in the millions or billions, especially with larger models that take care of computer vision and natural language processing tasks. So in the end, we see that we have a reduced control on some of the stuff that cybersecurity usually relies on. So what type of attacks does this imply? We'll see three types: data poisoning, adversarial inputs, and model privacy attacks. And in all these cases, we're dealing with attackers that don't have direct access to the model. So it's fully understandable that if somebody has the access to the model, then they can do a load of bad stuff to it if they want. However, in here, it's really all attacks that come from just interaction. So if we look at data poisoning, the idea is that attackers will try to provide wrong data so that the machine learning model is trained to make wrong predictions. And this has been an issue for Gmail in the past, where the spam filter depends on a series of components, not only machine learning, but they definitely use the spam reportings. So when users receive something they believe is spam, you can say, hey, this is spam, and Google will take this into account to improve the filter. It also can be, it has been at least attempted to exploit the other way, where attackers sent a lot of spam, and then they annotate it it repetitively as not spam. And we can see in the graph when these skewing attempts happen, so that after retraining, then the model will make mistakes. And maybe as something that has been a little bit more public a while back was Ty's bot for Twitter that Microsoft made public, which really learned from the conversations with other users, and where it very quickly went wrong, and it started from from users basically trolling it or providing it with let's say content which is socially unacceptable, or interacting with vocabulary or ways that probably you wouldn't want to, then, and providing it with fake information. And then after a while, the bot started repeating it. Actually, this happened very fast. So here we see how two successful attacks or two successful approaches to skew a machine learning model. Another area is adversarial inputs, where instead of trying to edit the model by providing it with new or badly created training data, is really designing input in a way that will be wrongly classified. And this can also have a huge impact in real world systems. We've seen with autopilots. This is a huge topic for vehicle constructors, and I mean, even Tesla is hugely marketed around this. Well, even small modifications well, this one was fixed, but initially just putting a post-it on a stop sign would make it wrongly classified. This has been fixed, and now models are a little bit more robust, but actually not so much, where even small modifications that are not necessarily seen by a human or taken into account, at least not if you aren't looking for it, then will make interpretation completely wrong by the algorithm. And this also has happened with voice, and these examples are really quite cool, because when you hear it as a human, you wouldn't even notice that something is wrong. You will hear maybe some clicks or some birds or a little bit of noise in the background. However, your voice assistant will understand it completely differently. And this happens, both of these examples happen because machine learning models don't only learn what we see or hear, but they pick up on tons of different patterns which are underlying in the data, which can be exploited. Finally, the third type of attack is related to model privacy. So where the goal is obtaining information from the model. This can be either the training data. So this example dates back to 2015, where the researchers' goal was to see if they could rebuild faces that were used in the training set. So obviously, well, we see the result is already pretty close. So by using the confidence of the model, they could slowly iterate until they found a picture which they thought was pretty sure in the data set. And for from one organization we've talked to, which has a ton of archives from the different world wars and annotated faces of a lot of people, also from non-Caucasian faces. So this is where there are a lot of data sets lacking. They are unwilling to train models on that, because they are for the moment too afraid of the risk that they can be reverse engineered. And it's not only about stealing the training data or getting a glimpse out of it, but also the stealing the model itself. So by querying the model with enough queries and enough examples, it is possible to rebuild a model that does the exactly same thing. So something that has taken a lot of time to develop, like this attack in on Google Translate that happened in this year, actually in January. Then by doing tons of requests, the goal was to try to reproduce the same model, which has taken tons of effort to build. So this gives us kind of an overview of what can happen, and it seems can seem very varied, right? So there are multiple areas where an attacker can pick on how to try to put into place a threat, or what might be their goal. And if we look into the recommendations of best practices, we find well, pretty typical stuff. So being able to understand the threats, so threat modeling, and then having an approach on how to deal with them, and then obviously staying on top of the subject so that you're faster than your adversaries, and security often becomes a game of cat and mouse. However, when we try to be realistic about it, there's only so much you can do, especially if you're starting. Not everybody's on the Google or Facebook scale of things. So to do this, there are two main pillars. One is awareness, which is key. So even knowing about something transforms it from this unknown unknown into unknown unknown. And it's also important to understand who should have this information. In software projects, things are getting more specialized by the day, and machine learning is one area where not everybody has the know-how on how it works or how to do it. So maybe expecting kind of your security team, which deals with networks, to suddenly also evaluate risks to machine learning systems is a little bit far-fetched. I'm not saying they shouldn't participate, but you cannot expect them necessarily to get everything done. So in the end, it's the experts of those very systems which can have the highest impact, since they can immediately make the link between what can happen and how to deal with it. And the second one is having realistic measures. So building a red team once when you have when you're just doing your first steps into machine learning, or when you have just your first application and you're already kind of fighting for that, then it's probably not something sensible. And now I'll try to revisit the previous examples that we saw before and show how, in some cases, very straightforward measures can take you a really, really long way. So if we look at the Gmail spam filter example, just making sure that you're not trusting blindly user input, well, it kind of solves 90% of the problem. So if maybe you will only take into account X submissions or X spam or not spam annotations per user, or you can simply look at the frequency, or if you want to make it even fancier, then yeah, sure, you can do anomaly detection as well and see if this works. Well, for the Microsoft bot, maybe a simpler maybe the lesson is just don't trust the internet, which I guess it's good that we're reminded from time to time. So those were pretty simple things where you do not need like experts to manage. Just some simple monitoring and being aware of the issue can practically solve it for you. And it gets trickier with other types of attacks. So when looking at adversarial inputs, there's only so much you can do. However, just looking at how many times can somebody query your model and making, and this also works for the model stealing, it will also be a great way to identify when something wrong happens, since to craft a successful input which is adversarial, then you probably won't do it just on the first try. It will take multiple attempts, and this is where your model is necessary. Obviously, if your model can be procured somewhere else, since it's open source or pre-trained, then it's harder to defend against this. But there are ways. And similarly to model privacy attacks, access. If just having sensible access policies can also make it so that your model can be useful to your users and that you can really exploit it without others exploiting it as well. Sorry for the pun. So I hope this gives you an overview of kind of where this is going, where we see, well, there's this hype around machine learning, and we start seeing, at least also from our customers, more and more projects which are getting implemented and put into the hands of users. And the same way, nobody wants to be the next ransomware headline in the news. Then you probably also don't want to have this stuff compromised. So I hope this can help you, and that at least this background is useful for you.